All right, CNT125 Routing Protocols Lab. We just got done working with RIP, our legacy distance vector. We're going to tear that off the routers and add OSPF. So I happen to be on the 2011, so I'm just going to use this one. I'm going to say config T, and I'm going to say no router RIP. And that'll take that config off. That is no longer there. And I'm going to turn right around and add OSPF. So I'm going to say router OSPF. And the number 2 here is a process ID. If I have more than one instance of OSPF running, which I could, this is a way to keep track of them. I'm just using the number 2 just because it's the number 2. Okay? There's no other significance other than that, and that it's a process ID. I now need to plug the networks in, but I need to use the inverse mask. Inverse mask, all right, let me get my notepad handy here. Notepad. If my subnet mask would be 255.255.0.0, the inverse would be 0.0.255.255. It's the opposite. So really, if I have a 255, I throw a 0. If I have a 0, I throw 255. Where it can get confusing is when I have this. If I have 240.0, it's like, I'm not sure what to do. Okay, well 240.0, 255, 255, 240 is this in binary. So if I do the opposite of that, that'll give me my inverse. While the opposite of 255 is 0, opposite of 255 is 0, opposite of this will be, try to line them up here, 2, 3, 4, that number right there. So this number right here, since we borrowed to 128, 64, 32, 16, since we borrowed to the 16 place, this number here will be one less at 15. So our inverse is going to be 15.255. That will be our inverse. So as I start plugging these in, instead of using the subnet mask, I use the inverse mask. So I'm going to say network 170, 70, and I'm going to use my 3 subnets back here, 16.0.32.0.48.0, so 16.0, and the inverse mask 0, 0, 15.255, area 0. That's essentially the backbone of the network. So we're going to put all these in the same area. So I'm going to hit the up arrow, and I'm going to do 32.0, hit the up arrow, and do 48.0, because all these have the same subnet mask, so they will all have the same inverse mask. I'm going to do exit, exit. I'm going to do show run on this guy. And here should be my OSPF config right there. Okay. Now I'm going to do something sneaky while I'm here. I'm going to highlight this right here. I'm going to control C that. You'll know why in a minute. I'm going to do copy run start. And I'm going to move my console cable to the other router. I was in the 2011, so I'll move it to the 4221. So now I'm on the 4221. Enable config T, no router RIP. I'm going to turn right around and say router OSPF 2. And I'm going to right-click paste. I'm going to right-click paste. That pasted those 3 in for me. I can do exit, exit, show run. And there is my 3 networks there. And I was already seeing messages roll by that it was like connecting up in the network. So I'll do a copy run start on this guy. And let's start looking at our network. What I tell you to do now is make sure you save. Make sure you can ping across your network. So I'm going to verify that. I'm going to redo my ping here. And I can. So that lets me know my network is still running even though I have OSPF on. Well, let's look at the routing table and start working our way in. So let's do show IP route. This time I'm on the 4221. You'll notice in the 4221, it's giving me a little bit more info. What I see here is I see the 16.0 network, 32.0 network, and the next line below it actually shows you the interface address. That's why it says /32. I see 48.0 network and I see 48.1/32. That's the interface address. So this router gives you a little bit more than the 2011. But there's my routing table. The 32.0 is directly connected on this port. The 48.0 is directly connected on this port. and the 16.0 network, I'm going to get there via this interface, then this router address, and it's a composite metric away. It's real easy to sit here and say, oh, it's 2 hops away. No, it's actually a composite metric. It actually uses a cost metric. The lower the bandwidth, the higher the cost. Since this is at least 100 meg link between, that's a pretty good bandwidth for routers. So it's a pretty low cost metric. So it's a cost of 2. If that started going up, these would be routes to avoid. And then here's your administrative distance of 110. RIP was 120. OSPF's a little bit better, so that number dropped down to 110 for the administrative distance. So there's my OSPF routing table. I'm going to save that while I'm here. Do a Control-C. I'll open up my notepad, and I'm actually just going to paste this right in so I have it. And I will do Save As. And I did RIP routing table before, so I will do OSPF routing table. And again, this is proof. This is showing that your network is up and running with OSPF. That's the only way you could get this complete routing table. All right, so there's my routing table. Now let's look at some OSPF events. So we'll do debug again. Debug IP OSPF events. I think that's the same command. Yep, events. That is now on. I might not see much because OSPF does not generate near as much traffic as RIP does. So what I tell you to do is go ahead and look at it for a minute, but then I'm going to disconnect the patch cable between the routers, wait a little bit, and then plug it back in. So I'm literally going to disconnect this crossover between the 2 routers. I just kind of pulled it out a little bit. I should see some events pop up here. It's saying, hey, the neighbor's down. This is the information that the router is getting, so it uses that to update its routing table. It's now basically saying, hey, I can't get there. That's down. I'm trying to learn. I'm going to plug it back in. And if I wait a second or two, you're going to see a whole bunch of like, hey, this changed. Hey, look at that route adjustment. Hey, I can get there. So this is the router communicating, updating its routing table for us, hence the term dynamic routing. That's why we're putting these routing protocols in. It's talking to the other routers, learning, and updating the routing table for us. So if I go back into a show IP route, I would see all 3 networks again. And there they are. Actually, here's the 32 and 48. It's still working on getting the 16 back in there because it went down. It'll hopefully be back in there shortly that we would be able to reach it. So I'm seeing link lights on. There we go. It's actually loaded that back in. So if I do a look now, I probably have it in there. There we go. So as you see, it does take a little bit of time for it to update its table, and now I'd be reachable. Now I'd be able to go back to pinging between those 2. I would not have a little bit ago when I had it unplugged. So there's a little bit of OSPF in the events it's triggering. Well, let's do another Wireshark. So I'm going to open up my little Wireshark fin down here. And this time I'll do another capture, again, Ethernet 3. I'm going to wait a minute and let a couple OSPF packets come in. So I'm going to pause while that's going on. All right, we've had it running here for a little bit. I'm going to put a filter in here, OSPF. There we go. We have had a couple packets come through. And you notice these are hello packets. I haven't had any links or anything go down, so I don't see any other traffic. These are just periodically occurring messages talking to their adjacent neighbors is what these are. Well, let's look at one of these. I'm going to open one of these up. If I look at the Ethernet header here, I see the source coming from a router going to a multicast, where it's going to a multicast. That is different. RIP was doing broadcast. This is doing multicast. If I look at the IP header, source is coming from the router 16.1. The destination is going to 224.0.0.5. Again, multicast. And super quickly, if you were to look at the Ethernet header again, okay, the source up here was the actual Cisco interface, 001795, blah, blah, blah. That's the actual Cisco router interface. If I look at the destination address, 01005E, that Ethernet front end, that front end of that Ethernet address, 01005E is a multicast flag. So when you see that at the beginning of a MAC address, this is a trigger, this is a flag to let receiving nodes know this is a multicast. Don't throw it out. Keep processing this to see if it actually is for you. So this is coming from the router going to other routers in the network, if you will, instead of the broadcast. So this actually helps update the network a little quicker than RIP did, which is why a lot of networks will use OSPF. All right, I'm going to save these while I'm here. Export specified packets. This I will call OSPF packet capture. Packet capture. And I'll leave the PCAP NG alone and just save these four that I'm looking at. And I will have those packets. Again, I could always pull that up at home if I have Wireshark installed and take a look at it. So there is my OSPF. Next podcast, we're going to come back, tear that off, and put on our hybrid routing protocol.